Welcome to this puzzle session. Here is the problem. Suppose A is a subset of the first 100 integers and the size of A is 10. We want to show that it is possible to find two disjoint non-empty subsets of A whose elements have the same sum. Okay, so pretty interesting. And as usual, you are encouraged to pause the video and try to solve it yourself. And let's now go to the solution. So for a subset, or before that, how many subsets of this guy are there? So there are 2 to the power 10 subsets of A. A is a 10 element set, so there are 2 to the power 10 subsets of A, but that includes the empty set also. So there are these many non-empty subsets of A. Right? These many non-empty subsets of A are there, and how many is that? This is 1023. Okay. Now, if A is a subset of, if S is a subset of A, and let's say S non-empty, then the sum of all the things in S it looks weird. What I'm trying to say is that just sum of all the elements in S. This is at most, it's a very bad bound, but it is at most 100 times 10. Because the size of S would be at most 10, because S is a subset of A whose size is 10. And anything in A has magnitude at most 100, because A is a subset of the first 100 integers. So we are summing up at most 10 things, each of which is at most 100, and therefore this is strictly less than 1023 is all that matters. Okay. So out of so many non-empty subsets, no two have sum greater than that. So we have more subsets and less room to fill them in. And by common sense or pigeonhole principle, it follows that thus there exist two distinct, I'm not saying disjoint, just distinct non-empty subsets S and T of A which have the same sum of elements. So explicitly for which this S, the summation of the things in S and the summation of the things in T are the same. Right, it is immediate from this conclusion. There are so many non-empty subsets, but the sums are not so many. So two must have the same sum. Right? So we have that, and now let's make a picture. So this is S and this is T. They can share some elements, possibly. Right? They cannot be, one cannot be contained in the other. If this was contained in T, let's say, then the equality means that actually S and T are equal. So S is not contained in T and T is not contained in S. So they may be overlapping, but they have their own separate regions. All right, but here is the final observation. Just throw away these common elements from both of them. The sum of these many is same as the sum of all of these. So if we just throw away, we'll see that the sum of the things here is same as the sum of the things here. So let's say this much is S prime. This much is S prime. Oops, ugly. And the other thing is T prime. So S prime and T prime have the same sum and they are disjoint because we have thrown away the common things. This is S prime, this is T prime, and S prime and T prime are, they satisfy the requirement of the problem. So let me not write that. So that's it. We have two non-empty disjoint subsets which have the same sum. So that's a very nice application of the pigeonhole principle. And as usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.